Welcome to Prudence Psychology 101. Today in this video we are going to look at the Mann Whitney U test, the definition of the Mann Whitney U test, and I'll solve one question from IGNO's question paper, previous year question paper. So let's begin. So what is Mann Whitney U test? The Mann Whitney Wilcoxon Rank Sum Test is a non-parametric analog of the two-sample t-test from independent samples. The Mann Whitney U test is a non-parametric test that can be used to analyze data from two independent groups designed when the measurement is at least ordinal. It analyzes the degree of separation between the experimental and control groups. The Mann Whitney U test is the non-parametric equivalent of the two-sample t-test. While the t-test makes an assumption about the distribution of a population, that is, the sample came from t-distributed population, the Mann Whitney U test makes no such assumption. So these are the key words that are very important when you write your exam paper. So now let's look at null hypothesis for the test. The test compares two populations. As mentioned above, the null hypothesis for the test is that probability is 50% that a randomly drawn member of the first population will exceed a member of the second population. An alternate null hypothesis is that the two samples come from the same population, that they both have the same median. The result of performing a Mann Whitney U test is a U statistic. For small samples, use the direct method to find the U statistics. For larger samples, a formula is necessary, or you can use technology like SPSS to run the test. So to find out U statistic, use this formula U1, that is for the group 1 U statistics, U1 equal to R1 minus N1 into N1 plus 1 divided by 2. Here R stands for sum of ranks in the sample and N stands for number of items in the sample. Similarly, you will do for the group 2, that is U2 equal to R2 minus N2 into N2 plus 1 divided by 2. So I will explain to you this with a problem. I'll solve the problem with this formula and then it will be more clear to you. So here is a Mann Whitney U test example from previous year's IGNO's question papers solved for you. So this is a question. Compute Mann Whitney U test for the following data. Group 1, there are some random 11 numbers. So the number of samples is 11 in group 1. And in group 2 also number of samples is 11. So our N1 is also 11 and N2 is also 11. And let's solve it. Before solving the problem, let me share some assumptions for the Mann Whitney U test. The dependent variable should be measured on an ordinal scale or a continuous scale. The independent variable should be two independent categorical groups. Observation should be independent. In other words, there should be no relationship between the two groups or within each group. Observations are not normally distributed. However, they should follow the same shape. That is, both are bell-shaped and skewed left. Okay. So now I would like to tell you the steps that you have to take to solve a Mann Whitney U test problem, and then I will show you how it's done. Okay, so the step 1 is rank the data, taking both groups together, giving rank 1 to the lowest score and the highest rank to the highest score. Step 2 is find the sum of the ranks for the smaller sample and find the sum of the ranks for the larger sample. Find U applying the formula given below. U equal to N1 into N2 plus N1 into N1 plus 1 divided by 2 minus sigma R1. And for U hyphen, that is U2, you have to find out N1 into N2 plus N2 into N2 plus 1 divided by 2 minus sigma R2. So this is the formula. Step 5 is look up the smaller of U and U hyphen in table H. There is a significant difference. If observed, the value is equal to or more than the table value. Then we will come to the result. So translate the results of the test back in terms of the experiment. So these are the 6 steps that you have to take while solving the Mann Whitney U test problem. So let's begin let's solve it. Okay, so they have given you two groups, 11 samples and the scores. Okay, so what I have done is I've taken up Excel sheet and I jotted down the group 1 in a vertical manner like this, the way I have shown it on the video, and then I have similarly done for the group 2. Now I look for the smallest number out of both the groups. Here 19 is the smallest number. If you see, I have ranked it 1. Then if you go to 21 in group 2, that is the second lowest number. So like that I have done. Third is 32, fourth is 40, fifth is 46, and sixth is 47, seventh is 49, eighth is 52, ninth is 63, and 10th is 71, 11th is 82, 12th is 84, 13 is 85, 14 89, and 15 is 91. Like this I have gone. I have completed the ranking, and once I have completed the ranking, the step 2 is sum the ranks in either group. So rank 1 total sum comes to 86. So our sigma R1 is 86, and rank 2, when you total it up, it comes to 167. So sigma R2 is 167. So now we know the formula, so it's easy to apply. So we know what is N1, that is 11 number of samples, and N2 is also 11. And then you just apply the number that you know, 11 into 11 plus 11 into 11 plus 1 divided by 2, and we know our sigma R1 is 86, so minus 86. So when you solve it, 11 into 11 is 121, and when you solve this one, 11 into 11 plus 1 divided by 2 comes to 66, and we know our sigma R1, that is 86 minus 86. So when you solve it, it comes to 101. So our U1 is 101. Now we'll calculate U2. The formula is the same, N1 into N2 plus N2 into N2 plus 1 divided by 2 minus sigma R2. So N1 and N2, 11, both are 11. So 11 into 11 plus 11 into 11 plus 1 divided by 2 minus our sigma R2 is 167. So U2 you will calculate when you solve it, it will come to 121 plus 66 minus 167 equal to 20. So our U1 is 101, our U2 is 20. So now step 4 is determine the significance of U. Decide whether you are making a 1 or 2 tailed decision. Compare the smaller value of U to the appropriate critical table value for N1 and N2. If the observed U is smaller than the table value, the result is significant. So now let's check the table. So before that, I would like to share a key concept with you. For Mann Whitney U test, the theoretical range of U is from 0. Complete separation between groups, null hypothesis most likely false, and alternate hypothesis most likely true. To N1 into N2, little evidence in support of alternate hypothesis. So in every test, U1 plus U2. So you know what is U1. U1 is 101 and U2 is 20. So 101 plus 20 is always equal to N1 into N2. That is, we know number of samples in both groups are 11. So 11 into 11 is also 121. So they both are equal. So when we solved our problem, it comes to equal. So we know we are on the right track. So in our example, U1 is 101 plus U2 is 20 equals to 121. It's equal to N1 11 into N2 11 equal to 121. The procedure for determining exactly when to reject null hypothesis is described below. So when I looked into the table, the critical value of U for N1 equal to 11 and N2 equal to 11, two-tailed alpha at 0.05 is 30. So you can see here I have showed you with the red circle, and I have also shown you the arrow mark. So it comes to 30. So what does our result say? Since the smaller obtained value of U hyphen is 20, U2 is 20, and it is smaller than the table value 30, the null hypothesis is rejected, and we conclude that there is a significant difference in the ratings given by the two groups. So this is a small sample, so it's easy for you to solve it. But what if sample size is large? When both sample sizes are greater than 20, the sampling distribution of U is for practical purposes normal. Therefore, under these conditions, one can perform a z-test as follows. The procedure to obtain U is smaller as in a small sample case, step 1 to step 3. Then the formula for z is applied as z equal to U minus n1 into n2 divided by 2 and divided by n1 into n2, that is 11, not total number of samples is 11. I am just giving an example here, divided by n plus 1 divided by 11. That is the total number of samples. The ranking procedure can become quite laborious in large samples, partly for this reason and partly because of violation of the assumptions behind parametric statistics becomes less important for a large sample. So the Mann Whitney U test tends to be restricted to use with relatively small samples. So when you conduct your research and if your sample size is large, it's better to avoid Mann Whitney U test. So thanks for watching this video. I hope it was very useful and I hope it was easy for you to understand. Thanks for watching and kindly share your feedback with us and do subscribe if you're not subscribed yet. Thank you so much.